Well, hey guys, welcome back to the channel and welcome back to the build of the Skymaster SU30 gigantic aircraft. This thing has been a ton of fun to put together so far. We, in the last video, did all the tail stuff, so the vertical stabs, horizontal stabs. In this video, we are starting to continue with the back end, but moving our way forward. Vectored nozzles, stinger, chute mechanism, wiring, central box, all that stuff. So let's dive back into this amazing aircraft. All right, last episode, we finished off with checking our stinger. We checked the left vectored thrust nozzle. So let's start working on this stuff. Now, before we think about putting these vectored thrust nozzles in, we need to do a little bit of digging here and confirm that we're happy with how everything is tightened up, installed. So we got some items here to check over, some servo arm, fixture, bolts and stuff to check over. So that's all the stuff that I can't trust manufacturers to just do properly. Maybe they'll surprise me on this, we'll see, but let's dive into checking over these nozzles. All right, so I've gone over each of the vectored nozzles here, and Skymaster did a good job. I gotta commend them, they did a good job. Basically, any of the fasteners that we don't have access to, it looks like they Loctited. The fasteners that we do have access to are not Loctited. So like these two guys as an example, Loctited those. The servo holding screws, Loctited those. Our golden clevises to all of our rods and everything, I put some CA on those. The servo set screws, soaked those in CA as well. You know, a screw like this, I checked that one, it was good. So good job, Skymaster, on that. That's job well done. So we got a couple things to figure out here. We got to figure out how we're gonna get all of our wiring complete. So we've got our wiring to do, obviously, for the vectored thrust servos, and also our wiring for the stinger. Now the stinger is pretty straightforward. Slips in. I think I'm gonna put the controller, the brake controller, up by the central box. That's going in the mid section between the two tanks. And what I've done regarding the mid central box is took the brace and put this piece of ply on there. This is, I don't know what size that is, maybe 3/8 ply. And this is going to allow us to mount the central box to a plate, and that plate gets screwed on here. So this, the tank slips in here. This actually goes in between our two tanks. So that's our central box mount. So we are going to put our central box right in this area. So that means all of our wiring essentially for the back end needs to feed right to this point. So what that wiring is our vectored nozzles and all the stuff in the back end here. Okay, so the way our pipe system works here is the exhaust pipe mounts in the fuselage, and this slips on, or the tailpipe slips into the receiver pipe just like that. So the receiver pipe portion is fixed right here. Everything behind that is movable. So the way these nozzles work is where they're marked left and right. This is the top here, this is the bottom. So I think what I'm gonna do as a first step is I'm just gonna take some thin pieces of ply and just lay them across the servos here. Now, so I'm gonna take a look and see what kind of plywood I have. Got to grind down those washers a little bit. And well, actually what I'll do is I'll put this nozzle on and we'll see how our spacing and everything works and where we're actually going to run the wires. All right, guys, so we got a plan in place for our wiring here. So I've cut some of our silicone high temperature wire. Now we've got some thicker stuff which is used for running turbine leads, but this is thinner stuff. I'll show you what it is. So it's this right here, so 22 gauge silicone wire. Let's take a look at our different wires that we've got available to us, and let's just do a little test. Okay, so we're gonna do a nice little simple test here, and we are going to run a timer, and we are going to have the wire underneath some heat for 30 seconds. And let's see what the condition of the three types of wire that we use is after 30 seconds of heat. So I'm gonna start the clock, and at the 5-second mark, we will put heat to the wire. And go. So I'm just going to hold this in the blue heat. So it's turning a little bit white. You can see the ends of the wire there glowing red. And there we go. So 30 seconds under the flame and really it's unaffected. There's a little bit of charring. The wire is actually hot, like back here it's hot, and the wire is totally fine. A little bit of the silicone has charred and flaked off, but otherwise unharmed. Next thing we'll try is some aviation wire. Now this is not silicone covered wire. This is not the stuff that is pretty common. A lot of people see this color and they think it's the really flexible heavy gauge wire. This is not. This is aviation wire. I get it from Thunderbolt RC in Canada, and the coating on it is very, very thin. I'll try and zoom in here, but I can actually see the strands of wire through the coating. So we'll do the exact same thing to this. Okay, my fingers are actually getting hot now. The wire's passing the heat all the way down where my hand is. And 35 seconds. Okay, so this stuff, it has started, just waiting for it to cool. It has melted itself together, but all of the housing is still perfectly intact. So that passed with flying colors. Both of those, great options. All right, next is Powerbox Maxi wire, and let's add some heat to this and see how it performs. Okay, so I had to move my fingers there because they were starting to get very hot. And this stuff was much like the aviation wire, so it started to melt itself together, but the housing is still intact. Didn't melt or anything like that. The housing actually stiffened up a little bit, so if I take this housing and bend it, it's kind of lost its elasticity, but looks like it held up just fine. Yeah, so you can see there it's basically melted itself together, but the wire strands are all completely separate still. All right, last piece we'll check is just like our standard connections. These come with a lot of different items, and the wire is quite a bit thinner gauge. So we'll check this one as well. All right, immediately very different results. So I'm not going to continue this test. That's going to be a very much a fail. So that didn't go so well. So quick little test on wiring. That's why we use the wire that we use. Now, out of the 3 successful ones, the silicone one is definitely going to be the most heat resistant. The other ones, they were melting together over a longer period of time. I suspect that the sheathing is going to start to melt even more. That's my thoughts anyways. So in this case, the ones that are going all the way to the back to control the vector thrust, we are going to use the silicone wire. The surfaces for the elevators and vertical stabs, we're going to probably use Powerbox Maxi wire, and good choices. Better than this option. So we've got all of our leads made up here and marked and everything. We've put our shrink tube labels on there as well, so that's all done. Next thing we're going to do is we're going to focus on our heat shielding for the servos. So I'm going to sand those little washers down, and we will plan out our heat shields. All right, so we got our heat shield in place. So what I did was cut a little block here of 1/4 inch ply, or I think that's 3/8 ply, and well, maybe 1/2 inch. Anyways, thick ply, screwed that in place, and then our heat shield gets screwed to that. Most of the support comes from the aluminum tubes there, and there's a shot of the heat shields in place. So we got one on each side, just thin wood, and we've wrapped the wood with metal tape. and that just creates a nice air pocket in between the servos and the pipe. So we've got our right nozzle basically installed here. It's not permanently installed yet, but this might give you an idea of how I did the cables. So there's one down here in the bottom, this guy up at the top. We've got them kind of safely routed in the exhaust vectored nozzle, and we're going to shoe goop these when we're ready to do a permanent like final install. That's just the plugs that I'm talking about. So what that means is when we are ready to do the final install, we'll shoe goop them, but they will still be removable if required. So this side's done, and I'm happy with it. I think that's good. We've got our wires run nicely so they're away from everything, not even remotely close to the pipes. And then we've got the excess wire to run forward hanging down right here. All right, and there's a pretty cool shot there of the tail vectored nozzles, turkey feathers, whatever you want to call them. SkyMaster also did a great job on these. I think the purpling and all that stuff looks really nice. Even from that point there back, it's a really nice look. So impressed, very happy with that. So wires, this is just temporarily installed again. I haven't run the wires to this point, so I'll do that next. But I just wanted to share that beautiful shot with you guys. Dancing tail time. So we got some advice here that if we flick this switch, SC, things go even more fun. So here we go. Up elevator, down elevator, right aileron, left aileron, and dancing tail time. All right, so kind of working away on the center wiring there with the central box because we need somewhere to run our wires to. Of course, we got our wires for the control surfaces back here. So I want to get that sorted out before we start running our wires forward. So just doing a little bit of planning here. This is the brace that sits and holds the front tanks in. And my whole plan here is to have the central box mounted, orientation right now doesn't matter, central box mounted to this board and the board screwed in to our wooden piece here. So then if we need to get the central box out, this is actually pretty accessible in this spot right here. So if we do need to work on the central box in this area, we can actually get access to it. So, but let's say that we need to actually pull this out for some reason, undo the front of the tank or the front tanks. They can slide forward a little bit, and then we can undo the two screws, which are accessible right there. This piece can come out and we can do whatever we need to with it. So fairly easy to remove, but also fairly accessible as well. So what we'll do is we're going to get the central box mounted to this plate with its stock screws, and then we will drill out our two holes that will mount the central box to the brace. So while I'm going through all this, I am doing some planning, and this is constantly going through my mind. So I just had the front end out here. I was kind of figuring where things are going to go. So we're going to have two air tanks on this aircraft, one on each side. Now, generally if you're not using a compressor on an aircraft, you want to have lots of air volume, but when you're using one of the V-Speak on-board compressors, it's kind of important that you don't put all the tanks in. So at the beginning of the day, it's very important that you fill up your air system with a manual pump. Now on this aircraft, if we only had one of the small tanks like this, then you could just fill the system with your V-Speak. The other way that V-Speak recommends is like not running any air tanks at all. I'm not a fan of that. I like to have a little bit of reserve. So on a plane this size, 2 of the air cylinders is plenty. We could actually just have the compressor fill those up. It's probably going to be fine at the beginning of the day, but anyways, we're going to put 2 of these guys in there. And then our V-Speak compressor, we're going to put right here. So I'm just painting a mount right now to glue into the fuselage. So V-speak's going to be nice and close to the air system. And so yeah, just doing a little bit of initial planning here. We've got the front board I've put over in the paint section. I'm painting some other pieces here that are going to mount to various components. And also have been working on the battery box here. So got that all assembled. I need to reinforce all the joints with high sol, so I've just tacked it in place with CA. So we'll get that glued up here shortly. And just over here in the back corner of the shop, painting some of the little bits and bytes that go in the aircraft, just getting that pre-done. And now we've got our board all finished up for our central box. So let's get our central box mounted and get the board mounted here so we can start working on that wiring. All right, so our mount's all done here. And of course our goal with this is you can access the central box. I mean, you can get at it, no problem. If you need to take it out, you can either pull this plate out if you're taking the tanks out, or you simply undo the Allen bolts on the side there and you've got access to those, no problem. And then you can just slide the central box out. And that's all sitting right in this area, so getting at those screws are pretty straightforward. They're gonna be roughly in this position. All right, and there's a shot inside with one of our tanks installed, and this whole assembly's been bolted in place. So actually you can see there, really good access to the central box, no problem at all. And then our wires coming out can just tuck over and slide down. So that works great. All right, so we've pulled the vectored nozzles off, and the point of that is now we are going to work on getting all of our wires run forward. So we have, of course, our vectored nozzle wires, and we've also got to make extensions for our elevator and horizontal stab and vertical stab servos there. So that is the next thing we're working on. All right, so we mounted the V-speak compressor to the board, high-soled the board to the fuselage, and used a little bit of CA to just spot glue it in place, so now I don't have to worry about that moving. The high-sol will cure. And also mounted the air tanks. So what I like to do with the air tanks is generally use silicone, because the silicone is removable if you ever need to get those tanks out. So I put a dollop of silicone around this part of the air tank. That is on the underside or the hidden side. So slid the air tank in, put a little drop of CA on the tank, used kicker to kick it off, and then I put a little bit of E6000 just in this section right here, and it flows around the air tank. So now the air tanks are essentially installed, and once that E6000 cures, it will be awesome. All right, again, just some more planning in the back end here. Kind of have my wiring figured out. Added a little bit of high sol to the chute carbon or fiberglass piece just to reinforce this area. Every time the chute operates, it's putting pressure this direction on these little tabs. So I just wanted a little bit extra reinforcement there. So just used a little bit of leftover high sol from our last mix. Now this wire is going to be cut down and shortened with this type of end on it. And then this is going to be our receiver wire for the chute mechanism. So this is a fairly tight area back here. Once we get rid of these wires, that'll be fine. So my initial plan is I'm going to put a piece of wood across the inside of this former piece. That's going to be where our chute mounts to. Now, I don't want to put our chute in this area in the actual stinger because our fiberglass is not crazy strong. So it would kind of make a lot of sense to put the chutes around this right here. But every time that operates, it's going to be pulling this direction. So I would rather, and also our chutes, they're probably going to come out the back here. And I don't want them to wrap around anywhere here because that's going to put a lot of force on the fiberglass. So I think when the chute comes on and off, we're going to have a wire connection and then a hookup for the mechanical system, which is going to mount to that former cross brace. That's my initial thinking. That may change, but I'm giving that some thought right now. Never used so much snakeskin on a build in my life. So we've got snakeskin on this wire, need to do snakeskin on that wire. ran our plug-in for our light on our vertical left stab. That wire's right here. This wire heads all the way forward. So with this wire, we are making our wiring assemblies here. So we're gonna have 2 of these guys go through snakeskin. One of them on the left side has that light wire go through, and just working on our wiring. All right, so we've got our wire all connected and run over to our center section. One little tip here for you, you can kind of see it on that side right there. For the snakeskin, if you want to fasten it down, I find something that works quite well if you're not using clips is put a piece of shrink tube over top of it and then tape or glue the shrink tube down. That works really well and nice and clean in the back of this aircraft. So we've run our wires to the center section here, and before we pull these forward, we're going to put our labels and our ends on our Powerbox leads. And once all of that's done, then we'll pull all these wires forward. So we'll do the exact same hookup on the right-hand side with the wires. It's going to be a little bit more simple because we don't have that light wire. So our wiring on both sides now is all done. Looks good, nice and clean. So we've got all of our wire bundles coming to this point. The last thing we have to do with this back end wiring is our little clips that we installed right there. Great adhesive on them, but we want to make sure we put a little bit of shoe goop on them just in case. All right, so I had an initial thought here to do a I don't know how to what to call it, a fixed plug system in the Stinger. Problem is that my concern here is there's a bit of movement in the system. So if I have the Stinger in place, the only thing that fastens it is the bolt holding it through the bottom. So the actual up and down movement here, or play, is all in the carbon rod system. Totally fine for flying, but I don't want to have that constant movement there on the plug. Now the MPX plug is going to be the best scenario for that because we have 6 pins, but to have that constantly moving up and down is not a good scenario. So I was going to take the MPX plug and mount it right there, but again, it's too much movement constantly. So we'll just go back to the normal plug system. We'll make this fairly simple to operate. So with one hand, you'll be able to plug that in and out. So pulled the tube out of the Stinger here. It's fairly simple. We just reach through the open end and undo the 2 screws. This all slides out. So the reason for taking this apart is I want to simplify the chute mechanism. So initially I was going to have the strings coming out and fastening in between the fuselage and the Stinger, but again, that's just 2 more things to connect. So I was thinking this structure here is definitely going to be strong enough. So what I'm going to do is put 2 holes in the fiberglass right there. The actual mechanism is here, so this is just all the motor, so nothing moves or happens in this area, and we can attach our chutes to this structure, which is going to support everything and eliminate the additional connections with the Stinger. So when we put this on, all we'll have is the single connection for the power and keep things simple. So we've got our chute installed, so it comes through the normal where the chute comes out, obviously, and we've got it wrapped around and installed with some fishing line. So after we install the fishing line, I put some of the rubberized CA on there just to hold it all in place and make it nice and strong. So that should work out just perfect, I think. So next thing we'll do is get this reinstalled back into the Stinger assembly, and then we're going to figure out the power situation. So we've simply just shortened the wire up here, put a piece of shrink tube on there to protect it as it's going to be going in and out and in and out as the Stinger comes on and off. And the simplest and easiest way that I could figure out to make the wire attachment easy is just put a little notch in the former work here, and we've just glued the plug down. So super simple to get to. You can plug it in before you even line the Stinger up here, and the Stinger is really easy to attach. All right, so installation, super simple. Obviously checking orientation of the plug. So we've got the plug installed, and then the plug just gets folded in the Stinger itself. Doesn't really matter. And that's that. So super simple. And there's one bolt that goes on the bottom that goes in the fastening tab. So while we're back here, we're going to cut off these sacrificial tabs. So these are removed. You can kind of tell just because they've chopped in when they routed these things out. So anyways, we'll just cut those guys off, vacuum up our dust. And pretty much at this point, everything from this point backwards is complete as far as wiring goes. Now the other wiring we're going to get accomplished right now next is the wiring from our wing servos or our Flaperon surface right here. So that's the next thing to do. All right, so our wiring for our Flaperon is all complete. We've tucked it underneath the former work here. It's encapsulated in snakeskin, and that goes to the center section and then forward. And those are the single lines right there. So at this point, we've got all of our wiring that needs to run from the rear end forward complete. So what we're going to do now that we've got our verticals off, is we're going to take our horizontal stabs. Actually, I guess we could just play with them like this. So we're going to get our cover plates installed, and that's pretty straightforward. It's just a matter of popping the cover plate on, drilling 4 holes, and using the countersink bit to make a little countersink, and putting the small little screws in. All right, so cover plates are installed. We also painted our screws, so they have disappeared. To get this bottom screw here, we did need to take the horizontal stabs off, so we did that. All right, so we started redoing things a little bit here on the, what we were calling the middle or slave central box. So we redid the channels here, simplified things a little bit. So we've got our chute on channel 9, air brake on 10, left throttle, right throttle on 11 and 12, nose wheel steering on 13. We did these before, the telemetry sensors on 14 and 15. Now what that leaves is that leaves E1 R3 open. Now, we have some ideas here on how to simplify this aircraft even more. So we're going to now use this central box, the mid one is what we were calling it. This is going to be our primary central box, which makes sense because all of our surfaces except our Flaperons are in this central box. The 320 that was supposed to be located in the nose is going to be way empty. So we probably only fill one side, if that. And the way we switch this around is this now becomes our primary. We're going to use E1 R3 as an EX output, and that's going to go to our new front box, which we're going to get a matching 210 and replace it for the 320. And that's going to simplify things. We're going to still be able to use all of our telemetry and everything, so that makes a lot of sense. And there's no reason to have a big unit like this in the front. Now, if we were using the voltage regulation built into the 320, that is fine. Maybe we would keep it, but there's really no reason to keep this heavy unit in the front. So we're ordering one of these guys. We have to wait for it to come in, but that's not going to stop us on moving forward with this. It does change how we wire things up. So now our receiver is going to come into this unit instead of the 320. So to simplify this, we're basically just flipping things backwards. So the primary receiver has been put into R1 on the central box. We're removing the 320 from the system. And then all we have to do is come into our programming here. And really the only change we need to make is our expander on the 210. So we'll just start from the beginning and go in here. So we've got our CB210. We're going to go in there. General settings, expander settings. So E1R3 jetty box, we're going to switch this to an EX bus. And what that's now doing is that EX bus is our output on E1R3, and that is going to send the signal to our front box, which is going to be a match to this one. Okay, so we're moving forward a little bit from the tail section here, and we are coming to our canards on the front. So these are pretty straightforward because they're not movable. There's no servo that connects to them. There's a couple key points with the canards. Number one, they need to be set with 25 millimeters of up. So up being the back end, up, as in up elevator kind of thing. So what you do is we're going to measure 25 millimeters from the leading edge here down, and that's where we're going to set that up. Now, the way it works is there's this cylinder here, which is like a hydraulic cylinder. So the Canard moves up and down through the damper, I guess is a better word to call it. So it's got a little bit of movement during flight, but that's the system. Pretty simple. Let's pull all the other parts out for this. All right, so we're just prepping our damper cylinders here, putting a little bit of blue Loctite on the threads, threading the metal ball joint on. I put just a little bit of side force on this, and the plastic end snapped. So I'm happy that it happened now and not in the air, obviously. So we're going to change both of these guys out. Okay, so we had our other one break on us. So we took them off. These are the Skymaster ones. Now, just a thought here. This was sitting in the bag. The dampers were sitting in the bag, and there was some shock oil in here, so it was kind of wet. I don't know what they put inside here, but I think it affected the plastic. So we've taken both of those off and switched them out for Dubro 256 ball joints with 440 rods. So these fit on the 3mm threads, no problem. Our length of the entire piece here is identical. The only difference is the stock ones use a 2mm threaded piece that's going to go through. We're going to switch that out to a 256, which is better. It's a little bit thicker, so no problems with that. All right, so I think we're good to go with our dampers here. Now, there is no notches or flat spot or anything on the Canard where the arm attaches. So it's just a friction mount. So I've pre-done all of our mounting here, and I think it's going to be easier to install that way. So that is... that's ready to go in the plane. Okay, so we've got the dampers just sitting in there, kind of getting things lined up. And it looks like it's going to be a fairly straightforward setup here. So we'll put our nut, our keeper nut, holding this side on first. And then we've got access to those screws down there because we need to put Loctite on the screw still. So we'll kind of get that snugged up. And then we will add our 25mm of position on the surface itself. All right, our Canards are done and they look pretty. Kind of a weird setup. I'm not really sure how they work, but obviously they're successful because lots of guys are flying these planes. But so our full down or full up motion with reference to the back is 25mm as per the manual. And of course, because this damper cylinder has lots of movement, we can do that too. So kind of weird, but they're just going to obviously move in the airflow, but it's quite a simple setup. We've Loctited obviously the arms and everything, nylon lock nut on the bolt nut holding the metal ball joint onto the fuselage. All right guys, and that is video number 4 complete. We accomplished some pretty awesome things in this video. Of course, the vectored nozzles, the stinger, we've got all of our wiring run to the midpoint here, and we've got our Canards installed as well. Lots of great progress on this aircraft. Couple things before we wrap things up. Don't forget to check out the Lighter Side of RC After Dark. You get to see a lot of this stuff way ahead of time. For example, this video that we recorded is coming out 3 weeks before the last After Dark, which the people in After Dark actually saw this. So definitely check out the Lighter Side of RC After Dark. Also, don't forget channel memberships, links down below. You can see videos well in advance. Usually a week or two we've got uploaded to YouTube. So if you're a channel member, you get to see those videos well in advance. And thank you to the channel members that have already signed up for that option on the channel as well. We truly appreciate it. Last thing is our podcast channel, RC Air Experience. There's a link down below to that. I'm not really sure because these videos are far in the future when that's going to be starting, but definitely check it out. We've got some fun people in the industry lined up, and it's going to be a good time. So thanks guys for watching, and we will see you in the next video.